China didn't just land on the moon. They landed right inside its deepest, most dangerous wound. Imagine a place that has hidden its scars from the eyes of all humanity for billions of years. A place where the silence is so heavy, you could almost touch it. On January 3, 2019, the Chang'e 4 probe pulled off the impossible. It touched down where no complex machine had ever dared to go before, the far side of the moon. But this wasn't just another victory for engineering, and it wasn't just about planting a flag in the gray dust for political clout. No. What the little U-22 rover found crawling across that ancient regolith made astrophysicists around the world freeze in their tracks. We're used to seeing the moon as a loyal guardian, a romantic lantern in the night sky. But the data streaming back right now from the Chinese probe is shattering that idyllic image. It tells us that our satellite isn't just a dead rock. It is a massive archive of the apocalypse. And the scariest part of this discovery? The story of the moon's destruction is a rough draft of what could have happened, and might still happen, to Earth. The Chinese mission found traces of an impact so colossal it should have torn the satellite apart. They found materials that shouldn't even be on the surface. And today, we are going to break down this detective story to the smallest detail. We're going down into a crater deeper than the Mariana Trench to find out why what lies there scares scientists. We'll understand why the silence of the far side is actually the loudest warning for us all. Get ready. We are heading into the shadows. Let's stop for a minute and understand exactly where we are. Why do we talk about the far side as something mystical? After all, the moon is a sphere. It spins in space like any other celestial body. So why, throughout human history, from the first people looking up at the sky to the age of telescopes, have we only ever seen one face of our satellite? The answer lies in a phenomenon astronomers call tidal locking. It's not an accident. It's the result of a gravitational dance that's been going on for over 4 billion years. When the moon first formed, it spun on its axis much faster. But Earth's gravity is a ruthless force. It pulled harder on the side of the moon closest to us than the far side, creating colossal friction inside the rock. This friction acted like a brake, slowly but surely slowing the satellite's spin. This process continued until the moon's rotation period perfectly matched its orbit around Earth. 27 days and 7 hours. That's exactly how long it takes the moon to spin once on its axis, and exactly how long it takes to orbit our planet. This synchronous rotation created the illusion of a frozen face. We were trapped by perspective. For centuries, people guessed, what's over the edge? Ancient myths filled the far side with monsters. 20th century sci-fi writers built alien bases there. But reality turned out to be far more complex and interesting than any fiction. When the Soviet Luna 3 station beamed back the first grainy, blurry images of the far side in 1959, scientists were shocked. They expected to see the same thing as the near side, huge dark spots we call Maria or seas. These seas are hardened lava, traces of ancient eruptions. But on the far side, almost no seas. Instead of smooth plains, they saw a battered, plowed-up world, completely covered in craters. It looked like someone had taken a giant hammer and smashed the exact same spot millions of times. The geology there is completely different. The crust on the far side is much thicker. While molten magma easily punched through the thin crust on the near side to flood the lowlands, creating those seas, the thick armor of the far side held the internal fire back. The moon turned out to be two-faced not just visually, but geologically. And it is this thick, ancient crust that keeps secrets that were erased by lava flows on the near side long ago. That is why China went there, not just to look, but to read a chronicle that no one has opened for 4 billion years. Picking the landing site for the Chang'e 4 mission wasn't just difficult. It was a nightmare challenge that the best minds at the Chinese National Space Administration struggled with. You can't just point a finger at a lunar globe and say, "Let's land here." The far side is a mountainous hellscape. Huge elevation changes, deep shadows, and zero direct radio contact with Earth. To control the lander, China first had to launch a special relay satellite, Kueqiao, to a Lagrange point where the gravitational forces of Earth and the Moon balance out. Only after building this bridge for communications could they risk a landing. And they chose von Kármán crater. Why there? This crater, about 186 kilometers in diameter, is a perfect landing pad from an engineering standpoint. Its floor is relatively flat and flooded with ancient lava, which is rare for the far side. But for science, it's valuable for a different reason. Von Kármán sits inside a much grander structure, the South Pole Aitken Basin. Remember that name. It's not just a geographical point. It's the key to everything. The South Pole Aitken Basin is the largest, deepest, and oldest impact structure on the Moon, and one of the largest in the entire solar system. Imagine a crater that stretches from the South Pole almost to the equator. Its size is colossal. If this crater were on Earth, it would cover the territory from New York to Texas. The depth of this basin reaches 8, and in some places, 13 kilometers. It's a giant bowl punched into the body of the Moon at the dawn of its existence. Scientists suspected the impact that created this basin was so powerful, it must have punched right through the crust and scooped up material from the mantle, the deep layer that lies beneath the crust and is usually inaccessible. If we want to know what the Moon is made of on the inside, we don't need to drill a hole hundreds of kilometers deep. We just need to fly to the South Pole Aitken Basin, where nature did the digging for us. Von Kármán crater is located right there. By landing in it, the Chinese machine didn't just land on the surface. It landed in a time machine that took us back to the moment the satellite formed. Scientists hoped to find chunks of the mantle thrown to the surface billions of years ago. And, spoiler alert, they found even more than they were looking for. After a successful soft landing, which was a triumph of automation in itself, the Yutu-2 rover, or Jade Rabbit, rolled out onto the surface. Unlike its predecessors from the Apollo missions, which could only scratch the surface with scoops and drill a couple of meters down, Yutu-2 had an ace up its sleeve, or rather, on board. It was a high-frequency ground-penetrating radar, GPR, capable of seeing through rock and dust to a depth of 40 meters, with a low-frequency channel punching even deeper, down to several hundred meters. How does it work? Imagine yelling into a cave and listening to the echo. By how the sound returns to you, you can tell if the wall is far away or if there are turns. GPR does the same thing, but instead of sound, it sends electromagnetic pulses. These waves go deep into the lunar soil, bounce off the boundaries between layers of different densities, and return to the antenna. By analyzing the return time and signal distortion, scientists build a 3D picture of the underground. It's like an ultrasound, but the patient is a celestial body. So, the rover started driving, slowly, carefully, moving literally centimeters at a time. It scanned the depths of von Kármán crater. What it saw initially baffled operators back on Earth. We're used to thinking of lunar soil as a layer of dust with solid basalt underneath. But the Yutu-2 radar revealed a layer cake that looked more like the ruins of a destroyed city than calm geology. Under a thin layer of fine regolith, lunar dust, the radar found chaotic piles of rocks, boulders, and debris. These weren't bedrock. This was cosmic construction rubble. Layer upon layer, ejecta from one impact covered by ejecta from another, buried by dust from a third. The radar showed that the first tens of meters under the rover are a mixed-up mess of materials flown in from different places. But the most interesting part started deeper. The data pointed to massive blocks of material buried beneath the surface, which structurally looked nothing like anything found on the near side. These anomalies testified that the history of this place was filled with violence on an unseen scale. These aren't just sedimentary layers like on Earth, where sand slowly settles on the ocean floor. Here, every layer is an instant catastrophe. The radar allowed us to see a sequence of events. This layer is the result of the impact that created the nearby Finsen crater, and this deeper one is traces of an even older cataclysm. The moon appeared to us not as a monolith, but as a patchwork quilt stitched together by explosions. And analyzing these layers led us to understand the single massive impact that nearly destroyed our satellite. Let's try to grasp the scale of the event that created the South Pole Aitken Basin. When we say meteorite, we usually imagine a burning rock falling into a field, or, at worst, blowing out windows in a city. But what happened on the far side of the moon, about 4.2 or 4.3 billion years ago, doesn't fit into normal frameworks. A body possibly 200 kilometers in diameter slammed into the moon. That's not a rock. That is a full-blown asteroid, the size of a dwarf planet. Picture an object the size of a small country hurtling at a speed of 15 to 20 kilometers per second. The kinetic energy of such an impact exceeds the entire nuclear arsenal of humanity multiplied by millions. This isn't an explosion. This is the absolute annihilation of matter. At the moment of contact, the moon's crust didn't just crack, it vaporized. The shockwave traveled through the entire satellite, making it ring like a bell. At the epicenter, the temperature spiked to thousands of degrees, instantly melting rock to a depth of dozens of kilometers. A giant fountain of molten rock, vapor, and debris rose into space, possibly even escaping the moon's gravity, only to rain death back down later. But the most important thing happened in the center of the crater. The blow was so hard it blew off the crust. It exposed the moon's mantle. The satellite's insides spilled out. The South Pole Aitken Basin, 2,500 kilometers in diameter, is the scar left after the wound healed. If that hit had been just a little harder or at a different angle, the moon could have simply shattered into pieces. We got lucky. The satellite held together. But it changed forever. This scale explains what the GPR saw. Those layers of rubble are the mixed-up remains of crust and mantle that fell back down after the explosion. And this process didn't take minutes. The surface boiled and rearranged itself for millennia after the impact. The Chinese rover is currently driving across the floor of an ancient ocean of molten rock that froze billions of years ago. Realizing this changes our perception. We look at the moon and see a calm disk. But really, we are looking at a survivor of a cosmic shootout. The moon is a veteran that took a hit possibly intended for the entire inner solar system. And soil analysis conducted by U-22's spectrometers confirmed the scientists' wildest guesses. The chemistry of this place turned out to be completely alien. When U-22 pointed its spectrometers at the soil in von Kármán crater, scientists on Earth held their breath waiting for the graphs. The data, arriving via the bridge of the Queqiao satellite, became a sensation. The chemical composition of the regolith under the rover's wheels was radically different from the samples brought back by American Apollos and Soviet Lunas from the near side. On the near side, the soil is rich in feldspar, a mineral typical of the lunar crust. These are light rocks that floated to the surface of the magma ocean when the moon was still liquid. But in the South Pole Aitken Basin, spectrometers picked up high concentrations of iron and magnesium, as well as the minerals olivine and pyroxene. To a geologist, these words sound like music. Olivine and pyroxene are heavy minerals. They don't float, they sink. They make up the foundation of the mantle, the deep layer that lies beneath the crust. Finding this much olivine on the surface is like finding an apple core sitting separate from the skin. It is direct proof that the giant impact theory is correct. The hit really did strip away the crust and throw mantle material onto the surface. This changes everything in our understanding of how celestial bodies form. Before, we could only build computer models of what's inside the moon. We guessed what it was made of. Now, we can literally touch its insides. This soil will tell us how fast the moon cooled, if it ever had water inside its mantle, and exactly how it separated into layers. This is primary material. Material that has hardly changed since the birth of the solar system. On Earth, you can't find rocks like this anymore. Plate tectonics, volcanoes, wind, and water have long since ground up and melted down all the primary matter of our planet. Earth erased its memory, but the moon kept it. And now, thanks to the Chinese rover, we have access to this library of ancient elements. But why are these findings so important for us, living on Earth? Why should the chemical composition of a rock 380,000 kilometers away matter to a normal person? Because the moon and Earth are sisters, or rather, mother and daughter, bound by the catastrophe of birth. They formed in the same region of space, from the same material. And if the moon's mantle rocks tell a story of brutal impacts, it means Earth went through that same hell. It's just that thanks to its size and atmosphere, Earth managed to hide the evidence of the crime. Analysis of olivine on the far side is the key to understanding where Earth got its water, how our core formed, and why our planet stayed alive while the moon turned into a stone desert. We are starting to understand that the chemical history of our system was much more complex than dust just sticking together. It was a history of mixing, melting, and redistributing elements during monstrous collisions. And what China has found now is just the first chapter in a new book of our origins. A chapter that forces us to look at the ground beneath our feet in a new way. All these discoveries on the far side of the moon aren't just a story about a distant cold satellite. It's a story about us, about Earth. Looking at the battered surface of the South Pole Aitken Basin, we are essentially looking in a mirror. Only this mirror shows a past our planet preferred to forget. Earth and the moon exist in the same neighborhood of the solar system. They move together like two ships in an ocean. And if one ship got caught in a heavy barrage, it's naive to think the other stayed untouched. If the moon took a hit capable of piercing its crust and nearly cracking its core, it means Earth was taking hits 10 times more powerful during that same period. Earth's gravity is much stronger. It attracts more cosmic debris. We live on a planet that was beaten even worse than the moon. But why don't we see it? Because Earth is alive. Tectonic plates are constantly moving, recycling ancient crust. Wind, rain, oceans, and vegetation erase the scars. The Chicxulub crater that killed the dinosaurs was found with huge difficulty, and that was recent by geological standards. Traces of the early bombardment, the one happening 4 billion years ago, have been completely destroyed on Earth. The moon, however, is dead and static. It is the perfect witness. It remembered every blow. And the Chinese mission data tells us a frightening thing. The early solar system wasn't just chaotic. It was a meat grinder. The period known as the Late Heavy Bombardment was a time when life on Earth, if it was trying to start back then, would have been wiped out over and over again. We're used to thinking Earth is a safe house. But lunar data shows our house is built on a shooting range. We survived not because of special protection, but in spite of the statistics. Studying the far side of the moon, we are recovering deleted pages of our own biography. We are starting to understand the hell our planet went through to become the blue oasis we know today. And this understanding leads us to the next, even more disturbing question. When astrophysicists look at the data on the scale of the South Pole Aitken Basin, it's not the past that scares them. It's the present. For a long time, it was thought that such catastrophic collisions were ancient history, mistakes of the solar system's youth when planets were still forming and elbowing each other. We calmed ourselves with the idea that now all orbits are stable, all the big debris has already fallen or flown away, and we live in an era of peace. But the presence of such a giant structure, formed possibly later than we thought, forces us to revise our models. This discovery hints that the stability of the solar system might be an illusion. Large bodies can change their trajectories unpredictably. If something 200 kilometers wide could smash into the moon after it had already formed a hard crust, it means the mechanisms of chaos work longer and more complexly than we assumed. Scientists call this intellectual fear. It's not panic about tomorrow, but a realization of how much we underestimate the threats. We look at asteroids flying past Earth today and consider them dangerous. But von Kármán crater reminds us of scales we don't even factor into our planetary defense strategies. We are preparing to deflect flying rocks, but we are completely unprepared for bodies capable of redrawing the map of continents. The moon shows that catastrophe is not the exception, but the norm of cosmic life. Periods of calm are just pauses between impacts. And the more we learn about the nature of these ancient impacts, thanks to the Chang'e 4 mission, the clearer it becomes. Our civilization arose and flourished in an incredibly rare window of silence. We take this silence for granted as a guarantee of safety. But the cold rocks on the far side of the moon scream that there are no guarantees in the universe. And it is this knowledge, cold and ruthless, that is driving the world's leading powers to start a new race right now. Not for prestige, but for control. Let's be honest, the romantic era of space exploration is over. The era of pragmatism and hard geopolitics has begun. The Chinese Chang'e 4 mission was the starting gun in a race the world tried to ignore for the last half-century. By successfully landing on the far side, China didn't just show technological prowess. It staked a claim to leadership in the most strategically important region off Earth. Why have the South Pole and the far side become target number one? It's not an accident. The United States with its Artemis program, Russia with its Luna projects, India with its successful Chandrayaan, they are all aiming for the same neighborhood: the lunar South Pole. This is the new high ground that must be taken. Whoever controls the lunar south and the infrastructure on the far side will control near-Earth space in the 21st century. China has set an incredibly fast pace. They are already planning the construction of a research base. In response, NASA is accelerating its plans to return astronauts. We are seeing the formation of coalitions. Countries are splitting into blocs, signing cooperation agreements with either China or the US. This isn't just science anymore. It's a question of who will write the laws for the new world, whose communication standards, whose airlocks, whose navigation systems will become the global standard. This race is happening without loud shouting and banging shoes on podiums like during the Cold War. It's happening in the quiet of labs and offices. But the stakes are higher. Because this time, it's not about planting a flag and flying away. It's about staying. Staying where there are resources capable of changing Earth's economy. And right now, there are a lot of myths about those resources that need busting. When people talk about lunar riches, they usually immediately bring up helium-3, the miracle fuel for future fusion reactors that will supposedly solve all humanity's energy problems. Yes, there is indeed a lot of helium-3 in lunar regolith, especially on the far side where the solar wind has bombarded the surface for billions of years. Tons of this isotope could theoretically power Earth for centuries. But let's cut the sci-fi. We don't have industrial fusion reactors yet. Hauling helium from the moon right now is like flying firewood from Antarctica on a jet. Expensive, stupid, and useless. The real gold of the moon isn't helium. It's not titanium, and it's not rare earth metals, though they are there too. The real gold is water. Ice. That is exactly why everyone is rushing to the poles. In deep craters where the sun hasn't shone for billions of years, in eternal darkness and cold, vast reserves of water ice are stored. Water on the moon isn't for drinking. Water is oxygen for breathing and hydrogen for fuel. If you have water on the moon, you don't need to drag fuel from Earth, fighting monstrous gravity. You can build a gas station in orbit. The moon becomes a trampoline. With its weak gravity, launching ships to Mars or the asteroid belt is vastly cheaper than from Earth. Whoever owns the lunar water holds the keys to the entire solar system. This is logistics, not mining for export to Earth. China, by studying the soil on the far side, is looking for exactly that understanding of how volatiles are distributed. They are assessing the moon's potential as an industrial base. This isn't a gold rush in the usual sense. It's the creation of a beachhead. And resources here are a means of survival for an autonomous colony, not a product to sell back home. But there is another resource on the far side that you can't touch with your hands, but which for science is more valuable than any fuel. It is silence. We've polluted Earth not just with plastic and carbon dioxide. We've polluted it with noise, radio noise. Every second, millions of phones, cell towers, satellites, radars, TV stations, and microwaves blast out electromagnetic waves. For radio astronomers, Earth is a disco where they are trying to hear a person whispering in the next room. We have gone blind and deaf in the radio spectrum because of our own technological progress. The far side of the moon is the only place in near space that is always turned away from Earth. The mass of the moon itself, those thousands of kilometers of rock, acts as a perfect shield. It blocks all the radio noise coming from our planet. There, in the moon's shadow, reigns perfect radio silence. It is a nature reserve of pure ether. That is why scientists dream of putting radio telescopes on the far side. It would allow us to hear the universe in frequencies that are completely jammed with interference on Earth. We're talking about low-frequency waves. These waves carry information about the dark ages of the universe, the period before the first stars ignited. We could hear the echo of the Big Bang, which is currently drowning in the noise of our cities. Instruments on board the Chinese mission have already started conducting the first experiments in low-frequency radio astronomy. Modest ones so far, but these are the first steps. If we build an observatory there, it will be a revolution comparable to Galileo inventing the telescope. We will see the cosmos as it really is, without the fog of our own noise. But here arises a dangerous ethical question. Do we have the right to interfere? We talk about bases, mining ice, factories, telescopes. We plan to turn the moon into Earth's 8th continent, an industrial appendage. But do we ever stop to think about the consequences? The moon isn't just a rock in the sky. It is Earth's gyroscope. It is the moon's gravity that keeps Earth's axial tilt stable. Thanks to this, we have changing seasons and a predictable climate. The moon controls the tides that shape ocean ecosystems. Of course, humanity is currently too weak to accidentally knock the moon out of orbit or crack it open while mining for ore. Our technologies are nothing compared to the satellite's mass. But we know how fragile complex systems are. If we start massive ice mining, venting tons of water vapor into space, creating an artificial atmosphere around the moon from rocket exhaust and dust, how will that affect the thermal balance? How will the surface reflectivity change? We've already disrupted the balance on Earth, assuming nature was infinite. Now we are going to the moon with the same psychology. It's empty, it's dead, we can do whatever. But the question isn't whether we will physically break the moon. The question is, do we have the moral right to turn the unique archive of the solar system into just another quarry? And will our interference become that butterfly flapping its wings that causes a hurricane? We are intruding into a system that has worked perfectly for 4.5 billion years. And we are doing it without even fully understanding how it works. Ultimately, the mission to the far side of the moon brought us something more than gigabytes of data. It gave us a new perspective on ourselves. The moon hangs above us like a giant memento mori. Remember, you must die. It is a cold, lifeless world where the sky is always black and radiation kills everything living. It is a world where time has stopped. Every crater there is a scar from an event that could have erased a civilization. The moon took them for us. It is our silent guardian, reminding us with its battered face. Space is not friendly. Space is indifferent. We live on a tiny marble covered in a thin film of life, and we are incredibly, fantastically lucky. China's discoveries in von Kármán crater turned the moon from a romantic symbol into a stern scientific document. This document states, catastrophes are inevitable, resources are finite, and silence is precious. We have only just started reading this archive. We have only touched the dust on the cover of a great book. And what we read there will determine whether humanity becomes an interplanetary species or remains in history as just another brief flash on the third planet from the sun. China didn't find aliens on the moon. They didn't find pyramids or secret Nazi bases. Reality turned out to be more prosaic and, because of that, more majestic. The Chang'e 4 probe and Yutu-2 rover found proof that our existence is a miracle of statistical error. They showed us the abyss of time and violence our system went through. China didn't find a tabloid sensation on the moon. They found proof that Earth's peace is not the norm, but a rare stroke of luck. And the moon, with its scars on the far side, will now forever remain a reminder of the price of that luck. A reminder that hangs in the sky every night. And now, looking at it, you'll know what hides in its shadow.